Hello friends, welcome to bisptrainings.com. My name is Amit and today we'll see the live example of building complete HR analytical model. Okay. You might have seen multiple videos about introduction of dimension modeling and basics, but this video will talk about everything in practical, how to build entire HR analytical model step by step. There are total 25 videos in which we learn the whole data modeling. We would learn semantic data modeling using different BI products. So in today's session we are going to start data modeling. This is the first video in which we will talk about the fundamentals of modeling aspects and the business requirement. We'll see the same model in twofold. We'll understand the technical requirement of it, and we also talk about functional and business requirement of model. We'll see this in 4 steps. I would recommend you to see the whole video to have a complete understanding about data modeling and all the important aspects. In step first, we build the semantic data model. Today we are going to use Framework Manager. In subsequent videos, I am going to show the same data model in different BI product. We would be using OBI RPD, SAP Business Object, Cognos Framework Manager. We will also design the same model in a new generation BI product like Tableau and ClickView. So step first, we will build that semantic layer, semantic data model. In step second, we will identify the need and prepare our reports and dashboard. In step third, we will design our data model considering my business requirements for my business users, non-technical business users. We'll prepare a report in a way that it is self-paced reporting, self-service report. People can drag and drop and do some basic to advanced analytics. And fourth step, this would be advanced data analysis. I'll show you how to do predictive analytics. We would be using multiple product for predictive analytics, IBM SPSS we would be using, and SAS also we would be using for predictive analytics. So let's start with first step. What is the ultimate purpose of the business model? Okay. Let's try to understand the business background behind this. Okay. So what value we are going to add to the business by creating this model? How we are going to solve this step by step? So step first, we'll understand the objective of preparing HR model. What value addition services we are going to provide to the business. We see all the live example. What kind of report we are going to build on top of HR model, right? HR reports going to build on top of HR model. In order to prepare HR model, the step first, we need to identify dimensions, we identify fact, we'll see joins and cardinalities. If these terms are new to you, dimension, facts, I would recommend you to go through our fundamental video about dimension modeling fundamentals. There you find everything in detail. Next step, we'll identify, we simplify the dimension model. That's exactly the objective of semantic layer. So in semantic layer, we'll see what are the business needs and what kind of queries requires to customize join. By default, all join database joins are coming from data source, but there are some scenarios where you need to customize those joins. What are the scenarios under which you need to write custom defined calculation? How do you apply basic to advanced filter, global filter or local filter? How do you create a business logic? How do you identify which confirmed dimension should be used? What is exactly confirmed dimension? In theory you learn multiple times, but you see live example of confirmed dimension. We also see the scenario where you need to convert snowflake model to star schema, or you continue to use a snowflake model. We'll see the scenario business requirement where we need to address many-to-many join. We'll talk about scenario where we need to create factless factable. What kind of business query needs a factless factable? And where do we need aggregation and how we can speed up query performance by using aggregation, aggregate tables. This all we see in a context specific. We'll see the context, problem, and we talk about them in solution. And finally we prepare some complex scenario like role playing dimension, degenerated dimension, junk dimension, and semi-additive and additive measures or facts. So ultimately, what solution we are going to give to the business users? When you're working in business intelligence, you are working close to business, and it is utmost important for you to understand the business requirement and the way business think about it. So what kind of solution we are going to give to the user? First, we are going to provide a one centralized place for all kind of business queries, data repositories. So people are using, my business users are using multiple reporting tool. Primary, the people are using um, Excel sheet for personalized analytics, and they're using various tools and means to present the data. We are going to give them one centralized place where they can query the business data. First advantage, we are going to provide some meaningful information to the user, fact-based meaningful information, on top of which my users can take up some important decision. It's called creditable facts. Some basic examples, like the HR manager would like to identify the best vendor for training delivery. So depends upon uh, previous delivery or historical delivery or vendor performance, we would identify who is the best vendor. Looking at the historical trends, we also like to identify the employee. We like to evaluate employee survey. There are multiple means and resources we have to conduct employee survey. Which source or resource is more appropriate, cost effective, meaningful to conduct an employee survey? We have multiple options, and which option we should select? It would be fact based decision, based upon historical analysis, or the facts numbers are available to us. Okay. And next important thing, we are giving a non-IT driven solution. BI should be non-IT driven, in which a business user can take up some important decision without or very less on IT dependency. The lesser dependency on IT, the low cost solution, and the more adaptability. So our solution should be non-IT driven, and the solution we are going to design in a way that later on the user can perform predictive analytics on top of this, which is very important, which will help them to identify new opportunities for more quickly. This is all we are going to see step by step. So step first, the best way to start learning is to look at the requirement and what people are needing. The first step, we will build the dimension model. Okay, so I'll take you to the requirement directly in order to make it easy to understand. So this is my data model we are going to work today. This is subset of my data model. I'll show you the entire data model, and I show you the complexity associated with this, and why we can't use the whole data model. We use a concept called divide and conquer. Divide the whole model into small pieces and start solving it. So the first part of our data model we are going to solve, it called HR expense. This is a model we are going to solve. Employee expense, direct or indirect expense we like to find out. And you see, if you look at carefully, in this model I focus only on one fact table, employee fact. Although there are multiple fact table, but here we focus only on one fact table, employee expense fact. And there I have a couple of dimensions, and some of them we have got lookup tables as well. So this model we are going to solve. And we have a list of queries from the business. I like to ensure the data model I am creating meeting up my business requirements or not. It is not like blindly we are creating model regardless paying attention whether your model is meeting up business needs or not. We'll see couple of business requirements, and after creating model we'll test them. For example, the data model we are going to prepare must meet up these requirements. First, the model should answer the employee expenses across different accounts. Across employee expenses by each year, employee expenses by employee, employee expenses under a specific manager, type of employee expenses, right? Employee expenses under specific employee positions, okay, and various parameters we'll talk about in order to ensure the data model we prepare meeting a business requirement. We'll prepare step by step. So let's start doing it live. First I'll show you the whole data model, okay, and I show you how complicated it is to directly start building report on top of this. And why we need to split this model into multiple small pieces? So there are the model we are going to see, we'll split this model into close to 12 pieces. We'll solve the independent problem and then we merge them. So we split it logical units and then we merge them to form an entire universal model. Let's create a new model. I named it as HR model, which is already there. I'm going to overwrite HR model. I create version 1. I use language, English language, and already prepared data model. I use data source. My data model is Oracle, and I use HR model as my database connection. My HR model exists over here, and I select required set of dimension. To expose you the complexity of the model, I select all dimension and fact. My idea over here is to showcase you the kind of complexity you have in the whole model. I bring the whole model considering only primary key and foreign key. I import, and this tells you the problem that why can't we use the whole model in one go, and why there's a need of splitting into multiple pieces. It takes some time to import because the number of dimensions are really high. 113 relationship, 66 dimension and fact, and relation between them 130, almost twice. ID should be n minus 1. If there are n dimension, there should be n minus 1. This is your whole model. Okay. The first step I would recommend you to do it. Create new namespace and name it whatever you like to give. I am naming over here as physical unmodified model. Physical unmodified model. Right. And keep all the dimension fact under this model. And as I am going to solve it, I split into multiple namespaces. This is a physical unmodified model. Look at the diagram of it and look at the complexity of it. This is my model, and I'm sure if you look at the whole model in one go, it's pretty difficult for you to understand what is what. What does it consist of? It's very difficult to understand. So this is your actual model, isn't it? The best way to understand is to split this model into small pieces and focus on one subject area at a time. And the key to do this, identify the approach I'm going to tell you will simplify this model step by step. Because our focus area is only employee HR expenses, we will not go beyond that. We'll focus only employee HR expenses. This is my universal model. So I create new namespace and call this HR model. HR model unmodified. Right? I'll bring only required dimension fact pertaining to my HR. Okay, so let's focus on your HR model. So I am going to import once again required dimension fact pertaining to HR. HR model, I'll bring all the dimension fact from my HR model. Only employee related details. So employee dimension, employee expense fact, everything start with EMP. Right now I bring everything, then I split into multiple pieces. Right? I just pulled everything start with employee. I'm not sure whether it is correct or not. The best way to start doing it and start solving it. This is my employee model. Second level of filtering we done. Now under this employee model we focus only first part of this. So first part of our analysis is employee expenses. Identify the fact which talk about employee expense. Then identify the dimension which directly related with the fact or any lookup table. Let's do this live. So I bought entire HR model. Let's see this. Is it readable? Oh, it's not. It's still not readable. Okay. This is a whole model. Okay. I'll tell you what you're supposed to do it. Look at the all dimension entirely list of table. Identify the first fact table. Because in our requirement we need to identify employee expenses, direct or indirect. Employee expenses are stored under this fact table. Employee expense fact. Okay. So I create another namespace, create a new namespace called employee fact. I call this data mart. And in this I'll keep only this dimension fact. Expand this, and what all you need? You need employee expense fact and all the, you have a foreign keys over here. You need all the dimension which pertain to this primary key. For example, when I focus on this employee expense, I need data from date, organization, position, employee detail, employee expense type, and financial accounts. What all the foreign key you have, bring the respective dimension for the foreign keys. Right? Best way is run metadata wizard once again. HR model. Select your first fact table, employee expense fact from your HR model, employee expense fact, right? And first I need day ID. So day key I can see from my time dimension. I have a day ID, day key. Then second is organization key. Organization key I can get dim organization. You need to have a little idea about it, or I would recommend you to refer the document metadata dictionary document where you find all the required dimension and details. Dimension organization details. Do I have a lookup table also? If you have lookup table, make sure you include that as well. I have a lookup table because dimension table may have only keys. The real name we find under the lookup table. So I use dim organization name lookup. Third one is position key. So I take employee position, and have a lookup over here for employee position. Right. Fourth one is your employee key. I can keep an employee dimension from here. Fifth one is account key. So I say financial account, which may be part from here. Finance account dim, and I have a lookup table for finance account dim. Right. Last one is okay, done. So I only bought one fact table and all the deleted dimension under this fact table, and the same thing I continue to do for all fact table, and later on we merge them. I like to bring them only based on primary and foreign key based. Right. Import. It may possible some dimension remain unjoined. So we would join them based on our need, and after join them we'll apply the testing. This test, list of the query, look at each query and apply a test. This seems to be perfect and simple to understand. Let's look at the graphical view of it. I switch to diagram, and this is how it looked like to me. I convert this model to star schema and zoom in, zoom out to focus on. I want all the dimensions should join to my fact table, direct joining. So I organize them, and anything indirect join I like to remove it, except primary and foreign key relationship or lookup table. I see two dimensions are joining, I like to delete this. So this is a kind of star schema we are going to prepare, where I have dimension has a lookup. Basically it turns out to be a snowflake model. Let's look at one part of it at a time. So employee join with employee position based on position key, and always remember the cardinality should be one to many from dimension to fact, always. So cardinality is one to many. Right. Similarly, employee join with employee dimension. My fact, employee expense fact joined with finance account dimension, and then there is a lookup table because account dimension is only code or key. The actual name consists over here. In addition to English, the multiple language support we have. In similar fashion, we have got organization and time dimension. To know the model is correct or not, we'll apply the test. And we apply the test, and we see all the queries step by step and check if all queries are being satisfied, the model is correct. If you're not able to answer these queries, it means we need to redefine our model. That's the best way to understand. So first question, we would like to see employee expenses across different accounts. Right. So account information I can see from account dimension. I like to see account expenses, and they join based on account key. Employee expenses I can read from here. Not sure if it is readable or not. This is called employee expense measure. Employee expense measure, right? and I take employee expense measure, expense total. I select expense total. I select, they are joined on account key, so I use account key, and account and lookup table join on account code. So basically I need only account code, employee total and account code. Account code, English name, right? I'm just keeping the key for the sake of my understanding. So we need account code, English name, and the code, account name, English name, code, and account key. Select the required column, right click and test it. I like to see totals expense, so I'm applying a checkbox over here called auto sum. Applies test sample. Are we addressing all the questions? So look at this part. Across different account name, this is my total expenses, right? For example, benefit pension plan, total expense. Benefit miscellaneous, total expense. Benefit healthcare insurance, total expense. This is exactly what we want to find out. And therefore my first query, my data model successfully meeting the first requirement, right? Employee expenses across department. Now let's apply second test. Employee expense across different financial year or calendar year. To find this question, we go back to our data model and test it. Employee expense. Now I look at with respect to my time dimension. I have a current year over here. Basically it should be calendar year named as current year, and it is joining on day key. The lowest level of granularity is day, right? It means in this system we are capturing day wise. If we need to capture it at high level of granularity, to remodel our, maybe we need to add one more aggregate dimension which talk about granularity at month level. So right now I take expense and current year, right? Right click and test. Make sure your current year is a numeric. It should be identifier, not a fact. If it is not it become a fact, the year will also consolidate. So it would be something like this: 1999. It will add up with 2000, which is wrong. So year should be considered as attribute. Okay, it should consider as attribute rather than shouldn't consider as fact, which is wrong, right? So there's a property called uses property. Change the uses property to identifier. Current year, and total expense. Right click and test. Click on auto sum, test it. Perfect. I could see every year total employee expense. So my second requirement also met. This was second requirement. Employee expenses each year. Now third requirement, I like to see employee expenses for each employee. Employee wise employee expense. So maybe my business like to see total expenses we are being the direct and indirect expenses on particular employee. This is what my business like to see. So this question we can address. So to see employee expenses, I need a dimension which talk about employee. I have an employee dimension, and I need employee name. So I scroll down, I can select employee name and employee total. Select, test, and aggregate for each employee the total expense. This is a basic test we are applying in order to ensure our data first part of data model is correct. So it looks correct. First name and respective expenses. Third requirement also pass. Fourth requirement, we would like to check employee expenses under specific manager. There are multiple managers we have. Manager level 1, manager level 2, manager level 3, and so on. Manager dimension is hierarchy in nature. See, we have manager dimension. Where is that? Okay, we don't have manager. Day key, organization key, position key. Yeah, under position key we need a manager. So do we have position? Yes, we have position dimension. So you see, if you look at carefully, we have got position dimension. Okay, we have position ID. We're supposed to have position lookup table as well, because if I query my position dimension, I find only keys, right, which is not talking about any meaningful data to me. So corresponding to position, I need lookup table of position as well. That is the beauty of testing. When you test it step by step, you get to know about where your model is not meeting up the need. So I modify and run metadata wizard once again and add a lookup table for my position. I select my HR model and select my HR model, and I see position lookup table, employee position lookup, right? This is what I need, and I like to look up. And in addition to primary key, I also like to query join to be identified based on common column. I import this, and it should meet up my fourth requirement. Done. So where is your lookup? Lookup dimension, employee position lookup. Yeah, employee position lookup. Got it. Employee position lookup join with my employee table. I want it to join with my position. So I delete this join, and here I need a custom defined join. I join based on employee position code. Select both the column and join. Because it is lookup, so one-to-one cardinality also works. For one lookup code, one position code, there is one employee, one position key. Okay. So for each position, there are different position. You see position number in English, and then we have position key. Let's check and see how close are we to this requirement. Under each position, what is our expenses? If it is not meeting up, we'll see and remodel our. Okay, we are getting a lot of unnecessary records. Employee code, employee name. It is joining on employee code, so I select employee code as well, and employee total. Okay. Right click and apply test, apply sum. We are only concerned with the employee code and employee. So I could see under different position the total expenses. This is a two required column. For each position, the expenses are being incurred. You can further extend this query and add a specific year. I mean, as the requirement comes up. For a specific year under different position, what is my expenses? We can extend this. Right, for given year, under given year for a specific position, how much the money is being spent, right? We added year as well. So you can use all combination of dimension to make sure model is correct step by step. Then we like to, in the fifth requirement, we would like to see, we like to see employee expenses, different kind of employee expenses. How much money company is spending on training, how much money company is spending in benefit, pay and bonus. For each year, we like to see these employee expenses. Also, we like to see employee expenses contribution percentage. How much money company is spending on commission, on vacation or health insurance. This is what my business like to see. So fifth and sixth requirement we can see together. I like to see employee expenses across different account type. Okay, so I can use account key and account name. Let's test this. We should apply sum also. So this I get some meaningful information under different account type. We're getting different employee expenses, right? In addition to this, people who also would like to, business also would like to see in different organization, right? Under different managers. So I can further say employee total under different manager, which is joining on employee ID under specific manager code. Let's say under employee manager 4, employee manager 6, how much money we are spending. Select and test it. So you continue to test various combinations of dimension and fact and make sure your data model meeting up all the requirements. So in a similar fashion, you test all the queries. Employee department wise expense, employee position wise employee expenses, employee expense under specific account, employee expense under specific account type. This is how when when your model pass all the tests, your model is correct. I would also strongly recommend you to capture the SQL query against each model, which I have not done it. For example, I show you one case. We would like to see employee expenses under specific manager, right? For a specific year, I select combination of year, employee manager, and total expense. We test it. We should have chosen this total. So under specific employee manager, different year, what is my expense? You should also pay attention to the query part. And Cognos render two kind of query. In fact, all BI render two kind of query: native query and database specific query. So this is your physical query which Cognos has rendered. In case you are dealing with performance related issues or you want some customization, you can keep this query and hand it over to your DBA, or if you are good at data query analysis, you can take this query and do for further analysis. I copy this query, I put into my any SQL editor. I use PL SQL editor over here, and this helps me to understand how joins are being done. If joins have some problem during data test, this query helps us a lot. So this is the first part of our model design which we passed. Subsequently, in a subsequent session, I am going to show you how to build a model for expense forecasting, position data modeling, ranking data modeling, recruitment data modeling, succession data modeling. We prepare multiple models. And why we are preparing these models? Because ultimately we are going to prepare these 113 reports, 113 live reports we are going to create, which fall under different subject area. These are all live reports we are going to build on top of our data model. So these reports are recruitment related reports, internal movement, staffing effectiveness, employee turnover, employee engagement, cost of turnover, process, performance management, career management, all kind of reports, employee career, benefit, equity, demographic, structure, tenure, all kind of report HR uses. We'll talk about that. These are basic reports and dashboard design. Later on, for advanced data reporting, we'll also talk about different KPIs called key performance indicator. Your business or management would like to evaluate employee performance or manager performance. Different KPI we are going to find out pertaining to recruitment, pertaining to training, health and safety measures, employer loyalty metrics, working time indicator. There's so many metrics I identified. There are 14 subject areas and we have close to 120 KPIs we are going to build in our model. So the HR model and reporting system we are going to build is very robust and talk about all parameters of HR analytics. After doing this whole implementation of this project, somebody would have same experience as you will have same experience which any developer has, close to 3 to 4 year experience when you do the whole model. And the total time investment required in order to implement the whole project is close to 45 hours, in which 25 hours I'll give you live session including live data, reporting template, sample requirement, business design document, functional design document, everything you see and you do yourself to have a better understanding. Ultimately we prepare some template, report dashboard templates, and the first part of the reporting will be done. Next step we'll start with advanced analysis and monitoring, and third we use predictive analytic tools. So we are using combination of multiple tools to address one business problem. So first part of session ends up over here. In second part we'll see the second data model design and continue to see the second different data model design and report building. Right now I'm stopping over here. Should you have any question, please feel free to write to us www.bisptrainings.com, and do watch our remaining 24 videos as well. Thanks for joining today's session and have a great day ahead.